Okay, so here we are with our projections again. We're going to talk about perspective projection. So that's these projections where we have an eye point and the rays diverge. So what does this look like? On the left, we see the perspective projection. This is what we're used to seeing because our eyes work this way. Closer objects look bigger, further away objects look smaller. We should see a sort of natural look on this Lego car on the bottom. On the right, we see that in orthographic projection, everything has the same size. So this is one of the advantages of orthographic projection, but it doesn't look as natural. Things look a little bit weird. So we often want to set a perspective camera in our computer graphics worlds. So what are the parameters that we have to control? So here's our picture again with the rays coming away from the eye. Of course, we have a top and a bottom clipping plane and a left and a right. We also have something called the near plane and something called the far plane, which sets the range of things that we're going to see. In this drawing, they're called hither and yon. I think in every modern graphic systems, they're called near and far. So here it is drawn in 3D. We have the near and the far, and we have these things on the side. This whole thing is called a viewing frustum. Here's that word, frustum. So this just means a cone-shaped thing that's going away from the eye. So now we have a question. What matrix can do this? So here we've drawn it just in 2D. Here's our viewing plane, -1. Remember, our camera is defined to be on the origin looking down the negative z axis. So we want to take an xyz point and project it onto this plane. By similar triangles, we have the ending y point, y prime to -1, should be the same as y to z, right? These are similar triangles. So we have y prime is -y over z. So now the question is, what matrix can do this? So pause here and think about it for a little bit if you'd like to. So here's the matrix. It's a little bit of a trick. We can't do this in 3D only. So this is another reason why we have these 4x4 matrices to deal with 3D. We saw previously that translations required us to have this one dimension higher matrix. Perspective is another place where we need it. It's using something that we haven't used before. So we're going to ignore the z component for right now because we're trying to get x and y to the right places. And we're going to do something special with this fourth component. Previously, we always just had 0, 0, 0, 1 down here. And we always had a 1 in this last component, xyz1. And I said, oh, it doesn't really change. Now that we have perspective, it's going to change. This is called the w component. So our xyz, we have a w at the bottom of this. And we're going to have a convention that says the real point we want, so the y location of our point is going to be y divided by w. So if we multiply out this matrix, we're going to get the y, and then the negative z is going to come here because of this -1. And so when we divide by the w component, we're going to get the y prime that we wanted. So this is called homogenization, and it's also mentioned as a perspective divide. So what does this matrix look like in the end? There's a call, geofrustum. It's like the geoortho call. You set your left, right, bottom, top, near, far planes. You get some matrix that looks like this according to the math above. This is another view of the same thing. This GeoU perspective is another way to define the same thing. So we had geofrustum, where you specify the left and right. Geoperspective, we specify in an easier way. We just give a field of view, and then we give an aspect ratio. So that means how is the ratio of the width and height. And then we still have to give the near and the far planes to specify where the front and back of that we're going to cut off in our frustum. So what is this? It's just another way to get the same matrix. So this will specify the same thing as this with different sets of parameters that may or may not be more convenient. I recommend that you use this in your code, the GL perspective. You're going to find it in the matrix helper library that comes with our book, utility functions. So what's it going to do? It's going to take this frustum shaped thing, and it's going to squish it into the -1 to 1 box, right? It doesn't warp the world in a simple way. It stretches out the world. So another way to think of it, instead of we're going to take the frustum and turn it into this, is to ask what does it do to the objects? So if I have a square cube, then my cube is going to get stretched out so that the near part looks bigger and the far part looks smaller. So you can think of this matrix as something that stretches the world such that far things shrink down.